Morning students, I am Dr VIJAY BHANDARI, Associate Professor in SIRTS CSE Department. So let's start. The program number 5, the name of the experiment is find out the results of a random forest regression. So now, before we implement this code, uh, I will explain you random forest regression. So let's start. Every decision tree has high variance, but when we combine all of them together in parallel, then the resultant variance is low as each decision tree gets perfectly trained on that particular sample data, and hence the output does not depend on one decision tree but multiple decision trees. Here we will discuss the case of classification problem. The final output is taken by using the majority voting classifier. In the case of regression problems, the final output is the mean of all outputs. The part is called aggregation. After the aggregation, a random forest is an ensemble technique capable of performing both regression and classification tasks with the use of multiple decision trees. And this technique is called bootstrap and aggregation, commonly known as bagging. The basic idea behind this is to combine multiple decision trees in determining the final output rather than relying on an individual decision trees. Now we see here random forest has multiple decision trees as base learning models. We randomly perform row sampling and feature sampling from the data sets, forming samples data sets for every model. This part is called bootstrap. Now we need to approach the random forest regression techniques like any other machine learning techniques. These having some steps. Now first step is design a specific questions or data and get the source to determine the required data. Secondly, make sure the data in an accessible format is converted to the required format. Thirdly, specify all noticeable anomalies and missing data points that may be required to achieve the required data. And fourth one is creating a machine learning model. Now the last process is set the baseline model that we want to achieve. Okay, now this is the stage that we interpret the data we have gained and improve it accordingly. Now we will see the implementation code here. So in first cell, we importing the libraries, import numpy and p, and import matplotlib, pyplot, sqlt, and thirdly importing the pandas sql. Okay, so we have discussed in last experiment. There is the numpy and there is matplotlib and pandas. So here in the first cell, importing all the libraries is like pandas to give structure to our data, numpy to perform mathematical and other relevant operations, and matplotlib to create charts. So importing the data sets into next cell. Data set is equal to pd.read underscore csv. That is the position cell based csv. That is our data sets. You can see here. Data which we have downloaded from the UCI machine website, machine learning websites. Okay, so this is the data sets. So now we move to the next cell, splitting the data sets into the training sets and test sets. So now we are applying the cross validation techniques here, and we are importing the training test splits on SQL dot cross validations. And X train and X test, X Y train and Y test. So to train test split means that means we are taking the 20% of the test in sets data, where the random split is equal to 0 And now we move to the next part, which is scaling. So now we including the standard scalar on the scale level of pre-processors. So now we're putting the random forest regression to the data sets. Now we import the random forest regression methods from the SLN ensemble, and then we are creating our objects regressor equal to random forest regressor is applying on our data sets. So that puts the regressor method applying on X, Y, and Y. Now we're predicting a new results, that is the regressor dot predict and print by predictions. Now visualizing the random forest regression. So these are the naming the axis and y axis. PLT dot plotting the x grade regressor predicting the x grade independent variables and which is denoting by the blue colors. Now we renaming the titles for club random forest regressions and PLT dot x level regressions label and PLT dot y level cell label. And now we show our plot graph. Now we get the results. This is the results of a Rutherford plot random forest regression. So this is the results, and the data points is denoting by the red colors and blue color is denoting by the line. So when the position level increases, the cell will increase level by level. This is the perpendicular state. Okay. And which gives the accuracy of the line. So that's for the day. Thank you. If any doubt comes, please you can ask me. That's for the day. Thank you.